So today I will talk about our problem background on our project. So most of the drains available around tall buildings or on the side of the road will suffer from stagnant water when it rains or when the drain is clogged with rubbish or any object that can obstruct proper drainage. Water stagnation occurs when water stops flowing. So when this happens, it can become an environmental hazard. Too much standing water that isn't draining can damage flooring and foundation also, as well as creating a perfect breeding ground for mosquito that we already know that the mosquito can carry very harmful disease, right? So when the water drains from fixtures, it's likely already dirty. The pipe also cannot release the water from the property, usually due to a blockage. The water will get even dirtier, the blockage will worsen and cause the water become stagnant. Standing water also does not emit an odor on its own. The odor associated with stagnant water arises from organisms that already died in the drain because of the blockage to the stagnant water, because of the rubbish, and also any object that can disrupt the flow of the water itself. In order to solve this problem, we come up with a magnetic fluid switch level sensor to control and measure the depth of the stagnant water in a drain. This is to prevent overflow of the water in the drain and also to obstruct the pedestrian or drainage process from the drain to the proper place, and also it can also prevent the cause of odor pollution.
Assalamualaikum. My name is Naruna Jo binti Nazif Saifuddin. I will present about details and instrumentation control system design. Basically, the function of the magnetic fluid water level switch sensor is to detect the level of liquids and other fluids and fluidized solids, and it is made from hard plastic or non-magnetic metal such as stainless steel. The stainless steels will fluid within operates on the basic buoyancy principle, which is the buoyancy principle state that the force equal to the mass of liquid displaced by the object. And it is continuous level sensors featuring a magnetic fluid that rises and falls as liquid levels change. And the movement of the fluid creates a magnetic field. When the fluid leaves, the magnetic field will actuate the electrical or pneumatic switch. Meanwhile, when fluid falling due to falling liquid level, it will deactivate electrical or pneumatic switch. And it is using a permanent magnetic fluid level switch and read contact. The switching operation is non-contact. It will free from wear and needs no power supply. So for the summary, the all functioning of the magnetic fluid switch is fully independent of vibrations, bubble formations, foaming, conductivity, and harmful vapors. Next, we move instrumentation control design, which consists of block diagram, input, and output signal. For input, there are before that we choose to use the system with GCM or GPRS module. So the input consists of ultrasonic sensor, which is it is the electrical device that measure distance of a target object by emitting ultrasonic sound wave. Meanwhile, for the system, it consists two devices, which is Arduino UNO, which is microcontroller used to control the whole system. And for the GSM or GPRS, It is the module. It is a chip that will be used to establish communication between a mobile device or a computing machine. And for the output, we can see it. They are mobile phone and alert, either LED and buzzer. That's all from me. Thank you.
So next we move to predictive maintenance planning, which is a very important factor to the users to become more alert on the level sensor that we use in the drain to prevent any hazards happen. So when maintenance work require, this assembly makes sure that the pressurized line involved is isolated, depressurize and drain before starting any disassembly. If fail to do so, may result in sudden pressure release and subsequent severe injury or death. If the valve does not operate easily, check the internals of the valve. So on the slide, we can state several steps or the predictive maintenance planning to that can be used in our project. So the first of all is the support fluid and lever, so that the mechanical load is removed from fulcrum and hinge pins. The second one is remove the fulcrum bracket, check fluid for leak or damage, remove piston assembly, remove split pins from fulcrum, and last but not least is to make sure the fulcrum can move freely. There are so many more predictive maintenance planning that we already stated in our report, but we want to highlight on this point because this is more important to make sure that our magnetic fluid level sensor can function very well in order to prevent any hazards on the drains happen.
Assalamualaikum, my name is Nurhazki Muhammad Kasim. So I'm going to explain the example of transient response related to magnetic float water level switch. So what is transient response? It is the response of a system to a change from an equilibrium or a steady state. The transient response is not necessarily tied to events, but to any event that affects the equilibrium of the system. So this is one of the example of transient response for magnetic fluid level switch. Figure shows the oscilloscope screenshot for a current step from 0 to 50 mA T-res 0.5 ms with an input voltage of V bat 3.6 volt. The regulated output voltage with the dynamic CBBC in the figure A shows an OS/US of 480 mV over 400 mV with settling times of 2.5 ms over 2 ms respectively. Compared to the transient load regulation dynamic enhancement circuit, it shows an improvement of 2 orders of magnitude in the settling times and an important reduction on the OS/US voltage variation. So, what is OS and US voltage variation? OS is overshoot, means that the value of this transition is higher than the final value, where the figure C shows the zoom image for the overshoot voltage variation, while undershoot US occurs when the transition is from higher to lower and its value is lower than the final value, where the figure B shows the US voltage variation. That's all. Thank you.
Hi, Assalamualaikum. My name is Nur Hidayah binti Zulkifli. So today I want to present about how to ensure the stability. So we can ensure the stability from Rhodes-Hurwitz stability. First point is Rhodes-Hurwitz criterion states that any system can be stable if all the roots of the first column have the same sign, and if it does not have the same sign or there is a sign change, then the number of sign change in the first column is equal to the number of roots of the characteristic equation in the right half of the S-plane. For example, equals to the number of roots with positive real parts. Second point is, we have to follow some conditions to make any system stable. Or we can say that there are some necessary conditions to make the system stable. Consider a system with characteristic equation below. First, all the coefficients of the equation should have the same sign. Second, there should be no missing term. If all the coefficients have the same sign and there are no missing terms, we have no guarantee that the system will be stable. For this, we use Rhodes-Hurwitz criterion to check the stability of the system. If the above given conditions are not satisfied, then the system is said to be unstable. This criterion is given by A. Hurwitz and E.J. Rhodes. So the last point is, there are some advantages of Rhodes-Hurwitz criterion. First, we can find the stability of the system without solving the equation. Second, we can easily determine the relative stability of the system. Third, by this method, we can determine the range of K for stability. And the last one, by this method, we can also determine the point of intersection for root locus with n imaginary axes.
Hi, I am Anis Nabila Abdul Rahman. I'll present about reduce steady state error. To reduce steady state error, you must increase the gain. When you increase the gain, the natural frequency increase while damping ratio decrease, which will result in larger and faster oscillation. Possible to alter rise, settling and peak time by adjusting proportional gain. This shows that steady state error can be reduced by increasing the gain. Since all parameters depend on proportional gain, the control system response specification is limited.